Welcome to this show on chemistry, and we will be talking on balancing of redox equations. We'll be talking on balancing of redox equations. And now we are balancing redox equations. We know that some redox reactions, they take place in different types of medium. It take place in different types of medium. The reaction can take place in a neutral medium, or the reaction could have maybe taken place in an acidic medium or a basic medium. So balancing a redox equation, it is very important to know which medium is the reaction taking place in. It is very important to know the medium in which a reaction is taking place in. And then for a redox equation to be balanced, matter and the charge must be balanced. That is, mass and charge must be balanced. It means the sum of the charge in the left hand side of the equation must be equal to the sum of the charge in the right hand side of the equation. And if you have maybe m mass, let's say m mass of hydrogen going in for the reaction, then m mass of hydrogen should be at the end of the reaction. So those are the conditions in which we have about balancing of redox equations. That is what we have to first of all put into our mind, so that we can be able to see how we can balance redox equation in the best way. And now we see that since there are three media in which a reaction could be taking place, which is the neutral, the acidic, or the basic, it means each different medium is having its own way in which the equation is being balanced. Each medium is having its own way in which the equation is being balanced, and these different ways will be talked in this process. So here we are going to talk on balancing equations only in the neutral medium. You come in the other video, you will see where we balance electron in the acidic and in the basic medium. Now it's good for us to note down something. You know that redox reactions can be taken place in acidic, basic, or neutral medium, And now for a redox equation to be balanced, matter, and this matter is in the form of mass, matter and the charge must be balanced. So we are going to have the first equation. For example, we have manganese 2 plus iron 2 plus reacting to give us manganese 2 plus manganese, this should be manganese 7 plus, reacting to give us manganese 2 plus iron 3 plus. So this is the equation that we need to balance. And when you look at this equation, we see that there is a species which is being oxidized in the process, and there's a species which is being reduced. When you look at the oxidation state of manganese here is in the +7 oxidation state, and then moving to +2, this tells us that there is a reduction. Then you have iron here in the +2 oxidation state, moving to iron in the +3, shows us that iron is being oxidized. So we have to write the equation, but we have to write two half equations, one for the oxidized form and the other for the reduced form. So for the oxidized form, for the oxidized equation, we have iron 2+, which is moving to give us iron 3+. While for the reduced half equation, we have manganese 7+, moving to give us manganese 2+. Now, the first thing we have to do check is whether the mass is balanced. If we look at it, we see that there is one iron here and one iron here, which means that the mass is balanced. Same as for manganese, there's one manganese, meaning that manganese is already balanced. Then now, we check whether the charge is balanced. If you look at it, you see that there are two, the charge of iron of the left hand side in this equation is 2, meanwhile the charge here is 3. That's here is +2, here is +3. So we have to balance the charge, and for us to balance the charge, the only thing we can do is to add the electrons, and we will add the electrons to the side of more positive. We add the electron to the side which is having a more positive charge, and the electrons we are adding should be equal to the difference in the number of electrons from that where there are more electrons to that where there are less electrons. When you look at it, you see that there are more electrons here than here, and the difference is 3 minus 2, which is equals to 1. So if we add 1 electron to this side, this will balance with the number of electrons. So we add an electron to this side. Since the electron is minus, this minus square comes here to neutralize one of these positive ions to give 2+, which is equal to the 2+ here. So we say this half equation is already balanced. Then when we come to this other half, we see that there are 7 electrons here and 2. So the difference is 7 minus 2, which is equals to 5 electrons. So we need to add 5 electrons to this side, so that these 5 electrons can neutralize 5 protons here to have what? To have 2 as a charge and 2 as a charge. So we have what? Plus 5 electrons in this other side. Now when we have them as seen like this, we see that even if we are to add the two equations now, the number of electrons will not balance, because in the left hand side there are 5 electrons when we add, and in the right hand side we are going to have 1 electron. So for us to balance it, we have to multiply these equations. We multiply this equation by coefficients, and this coefficient you are multiplying, it will be the difference in the number of electrons. For the oxidized half, it means you are going to multiply the oxidized half equation with the coefficient of the number of electrons in the reduced half, while you are going to multiply the reduced half equation with the number of with the coefficient equivalent to the number of electrons in the oxidized half, meaning that in this equation we are going to multiply this equation by 5, and we are going to multiply this other equation by 1. So I have here times 5 and times 1. When we multiply, you see that you are going to be having 5 Fe2+ to give us 5 iron 3+ plus 5 electrons. Meanwhile here it remains the same, manganese 7+ plus 1 times this, that is 5 electrons to give manganese 2+. Now there is one thing we can make from there's an observation we can make from this. We can be able to see that the number of electrons must occur in both sides of the two halves. The electrons must occur in two sides of the both halves, so that when we add the two equations together, the number of electrons will cancel out, when you look at it, you see that there are 5 electrons in this left hand side and 5 electrons in the right hand side. And so if we are to add these two equations, we are going to have something of this nature. We have 5 iron 2 plus manganese 7 plus 5 electrons to give 5 iron 3 plus manganese 2 plus 5 electrons. But since the number of electrons are equal for both the left hand side and the right hand side, they cancel out and we are left with 5 iron 2 plus manganese 7 to give us iron 3 plus manganese 2 . And this is the final equation. It's a 5 here, and this is the final and the balanced equation. So let's check whether the charge on the left hand side is equal to the charge on the right hand side. Here we have 5 times 2 plus 1 times 7. This is the charge on the left hand side. Then we check the charge on the right hand side. We are having 5 times 3 plus 1 times 2. So when we do this, we see that here we are having 10 plus 7, and here we are having 15 plus 2. 10 plus 7 gives us 17, while 15 plus 2 gives us 17. So when you look at it, you see that what the charge on the left hand side of the equation is equal to the charge of the right hand side of the equation. This tells us that the charge is balanced. And let's check on the mass. We have 5 atoms of iron here and 5 atoms of iron. It means iron is balanced. And then here we have 1 manganese and 1 manganese. This shows that manganese is balanced. So thank you for watching this video, and we will plead that may you subscribe to this channel, and don't forget to come and watch the other videos of how to balance redox equations in acidic and in the basic medium. In the next equation we will be talking in the next in the other video, you will see how to balance equations in acidic and the basic medium. So please don't miss this opportunity. Come and watch the videos, then subscribe to this channel. Thank you.